This is John from caveofprogramming.com. In this tutorial we're going to refactor this basic SDL program a bit, and we're going to introduce a screen object that's going to encapsulate some of this code. I finally figured out what yellow is in red, green and blue. I really can't believe that I actually forgot that, but apparently it's red and green combined. If I can get this to actually run. Oh yeah, I need to stop Eclipse being full screen. So here it's yellow. I really don't know how I managed to forget that, but anyway. In a moment we've put everything in one main function, and I'd recommend you do that to get a demo program working that just demonstrates the basic things that you need to do with your program, things that you're not sure if you can actually get to work with your particular API on your system, like pixel access, or making a sound, or whatever it is. If there's anything you're not sure that your program's actually going to be able to do on your computer, then test it by following a tutorial, type stuff out yourself and get a main function working with just some code in it that tests the principle. But now that we've done that, we don't want to keep adding code to it, because it would eventually, by the time we finish the program, be really hard to understand what's going on. We'd have a huge amount in the main function. You could split it up into multiple functions, which is kind of the old C style. C is the language C++ was based on, and it doesn't have classes and objects. But we're going to use an object here because, after all, this is C++, and objects are a nicer way of organising your code than functions, or at least many of us think so. So let's right-click this project here. Well, I should just explain actually first that if we just look at this code, it's basically doing three things. There are three things that are really important anyway at the moment. There's the setup of SDL, which is quite a lot of code. There's the game loop here, and then there's tearing down SDL. We've also got some drawing code here as well. So one kind of candidate for parceling this into a class would be, we could have a class that does the setup and the tear down of SDL, and we could then think about where to put the other bits of code that don't quite fit into that idea. But we could have some kind of class which you could call SDL or something, but to avoid confusion I'm going to call it screen, because it's basically working with graphics, and we're going to put the setup and tear down code in that, and later on we'll think about moving other code into it as well. And for the moment I'm just going to concentrate on getting this into a class, and later on we'll think about how to arrange bits like this code, for example. So let's right-click the project here and go to New Class, and I'll create a class called Screen, and I'll put it in a package called caveofprogramming. You can call the package whatever you want, as long as it's not got spaces in it. And I'll click Finish, and here's our class files, the header and the CPP file. You'll notice that this SDL API that I've used just uses functions, not, at least this version anyway, it doesn't use classes, and they prefix the functions with SDL underscore, and that's because you want to avoid name collision. Your end user, the end user of SDL, which is us in this case, might have another function called, for example, init or create window or whatever. So you don't want that name to conflict with the SDL functions, and for that reason the creators of SDL have prefixed these functions with SDL underscore. It used to be common, and perhaps still is in C++, to prefix the names of classes in the same way. So you could have a class called C window or something, and the prefix C is there just to disambiguate it from window, which would otherwise be a very, very common name for a class. That's not really necessary anymore. Now we've got namespaces. Namespaces allow us to avoid name collisions in a more elegant way. So we can happily call a class window or screen, knowing that our namespace will protect us from name collisions, because we can select what namespace we use classes from. So the first thing I'm going to do is I'm going to I'm going to take out things like renderer, texture, window, and buffer in here and make them instance variables in screen.h. So let's go ahead and do that. So I could just copy this actually. So let's actually do it from the top. I'm going to get STL window in here, go to screen.h. I've just copied that. I'm going to create a private section here, private, and paste in that. And we also want the renderer. So we've got the window, the renderer, we've got the texture, and we've also got this buffer down here, which I'm also going to put into screen because it's pretty closely related to the other stuff that's being done here. Now, a convention that a lot of people follow, and that I'll follow as well, is that if you have member variables, you often prefix them with m underscore, just to make it clear that they are instance variables and not local variables. So let's do that as well. I think that's all good. We'll also take the screen width and height constants here, and I'm going to make those static constants, public static constants in the screen class. Public because we might need to refer to them elsewhere. Static because we only want one of them for the whole screen class. We don't need different values for each different screen object. And there's no problem accessing constants really from outside your class. You can make constants public if it's necessary to do so. And here, I think we're going to have to refer to screen width and screen height, quite possibly outside of the screen class. So we'll make them public static constants here. Let's give screen some methods. So I'm going to give it a constructor. I'm going to give it a method called init, which is going to return bool. It's going to return true or false. False if it fails, true if it succeeds. We're going to give it a void close, which is going to do the kind of deallocation code, the close down code. And I'll also give it a method bool process events as well, because we can put the event processing into this class as well. So it kind of looks like magic, the way I'm just producing these at the moment, but I thought about this quite a bit, and I tried a few different things out, and this is the solution that I settled on, and you'll see how this works as I go along. So let's copy these, because we need to create the method implementations in the namespacing screen.cpp here. We need to prefix them all with screen : to say what class they belong to. That goes right before the method name. And we need to get rid of this semicolon and put in the brackets that enclose the implementation. So let's just copy those, paste them into the right place. And finally, we'll use auto format to format that. There we go. So for the constructor, I'm not going to make the constructor do the initialization, because we can't return a value from the constructor to say whether it succeeded or not. The constructor could throw an exception, but we haven't looked at exceptions in this course. I'm going to save that for my next course, intermediate course in C++. So we'll just have this init method that can return true or false to say whether it succeeded or not. But we will have the constructor initialize the instance variables. Let's copy them, and for the minute I'll just paste them into a random space here, because I need to get rid of all these types. You'll see what I'm doing in a second, but I'm just trying to efficiently edit these. And to put them in the constructor initialization list, I'm going to initialize each of them to null, and then we need to follow each with a comma. So I'll do that with each of them, except the last one doesn't need a comma. And then let's cut those. So we'll put a colon after the closing round bracket of the constructor to form the initialization list here, and paste them in and use the format. And if we've got it right, it should format it nicely. We're getting an error here saying null is not defined. Let's go to screen.h, and that's because we need to include the stl.h, and if I include stl.h in screen.h, then it's because screen.cpp includes screen.h, that's also going to include stlh in screen.cpp as well. So let's include up here, let's include in screen.h, we'll include stl.h. Then hopefully, yeah, some of those errors will go away. So for init, let's put in return true, and we're going to put the initialization code in a minute. For process events, I'll just put return false, just so that it will compile for the moment, and close doesn't need to include anything there. So now we can go back to main.cpp, look at all our initialization code, and take it all out. And I'll also take this stuff that sets the pixel colors just for the moment, which isn't going to stay in the init function, but I'll put it in there for the moment, because my object for the moment is just to get this to compile in a more object-oriented form, and we can think about details afterwards. Let's cut all this and paste it into let's put it into screen.init. Let's have this render code in there as well for the moment. That's also going to move later on, but we're just trying to transfer everything in the simplest way possible to our screen class at the moment. I'll just format that. Now, if I save that, we should get lots of errors, because things like window are not defined, and we haven't included IOStream, so cout is not defined. I'm going to get rid of all the couts, and instead of returning an error code, return false from init, so that we can know that init has not succeeded. If it doesn't succeed and you want more information on why, remember you can always use stl get error to get that information, as you've seen in a previous tutorial. So let's change this to false. Get rid of this cout. This is false, so if it fails we return false. And here's another cout. This would have to return false. And then finally, if everything succeeds, we return true at the end. So the next thing we need to do is change things like window to m_window, because we renamed those there. And we need to get rid of the variable declarations, these local variable declarations. One really common error in C++ or Java, or lots of programming languages for that matter, is that you create an instance variable like this one, and then you try to initialize that in a constructor or an init method, and by accident you redefine it, so you do something like this. And this then masks the instance variable and doesn't do what you expect it to do. So when you try to use the instance variable later, it doesn't work. So you have to watch out for that. Don't accidentally redeclare instance variables as local variables. We need to get rid of this type definition and just use the instance variable there. So let's work through this, adding the m_prefixes and getting rid of the type declarations here. So I've got a window there. Here's a renderer. This texture needs to change to m_. So we need to destroy the window there. Here's the texture. Here's the renderer again. Here's the window. And now here for update texture, we've got m_texture. We've got clear the renderer. For the render copy, we've got renderer and texture m_, and here we present the renderer and actually draw it on the screen. So that looks pretty good. That might compile in itself, but we've got an error in main.cpp, so we've got to do something about this tear down code now, this deinitialization code. I think there's a word that I'm searching for to describe, closing everything down, but for some reason it's not coming to my mind. But anyway, we need to cut this stuff here and put it into our screen.close method. And we need to change these so they all also have their m_prefixes and they refer to our instance variables. And I'll just do a format on that and save that. Now I think this would actually compile. Let's put a screen object in here. Let's say screen, and let's say if screen.init equals false, or we could say if not screen init, cout error initializing STL. That's not a pretty message for the user, but as long as it's only something we're developing on our own machines, then it's fine. At least it tells us what's happening. We need to include the screen.h at the top of main.cpp so we can use the screen class. Remember, you need double quotes, not angle brackets, because it's a local include. It's not in a standard directory. Save that. Hopefully these errors will go away very shortly. And down here, after the game loop, we need screen.close. Now let's save everything and see if it works. I'll go to build project. So another thing I've forgotten is I forgot to say what namespace I'm using here, because we put the screen in the Cave of Programming namespace. I'm not going to prefix screen with that namespace. I could do, but I don't need to, because I don't think there's not going to be any other screen class in our program. So I can just say here using namespace Cave of Programming. Let's try that. So build this. Hopefully the errors will go away. It seems to have built without any errors, which is good. Let's run it and see if it works. Yes, so it works. That's really good. We could also put this event code somewhere into screen. Now, I thought about putting all of this loop here, while not quit loop, somewhere into screen, but that's not really good, because in this loop I want to draw particles, and I don't want my particles tied to my screen stuff. What I want to do is create a screen class that I can reuse in other programs, programs that have nothing to do with particles. So I don't want to put the whole loop into screen, but this bit is just the bit that basically closes the screen if you click the cross on the corner of it. So why not put this into the screen class as well? Let's cut this and go to screen.cpp, and in process events I'm going to paste that in, format that, and what I'll do is, instead of saying quit equals true if we get the quit event, I'll return false from the function, otherwise I'll return true. So now we've got this loop which checks all the events, and if any of them are type STL quit, it returns false from this. Otherwise, after finishing checking all the events, it will return true. So let's go back to main.cpp, because we need this declaration of STL event in here. I need to put that in there as well. So now all we have to do is, every time we go around our loop, we call screen.processEvents, and we say that if this is if not screen process events, or if screen process events is equal to false, it doesn't matter. That means that the quit event was received, and that means that we can quit the loop. So we can just say break now, which will break this outer loop. In other words, it will stop it running. And now we don't even need this quit thing, really. We can just say while true, have an infinite loop, and we'll use break to get out of the loop if process events tells us that the STL quit event has been received. I'm going through this quite quickly, but I'll make the code available for you to check on caveofprogramming.com or wherever you're watching this tutorial, except on YouTube, where I can't attach files to YouTube, but everywhere else I'll ultimately attach the code to the lecture where possible. Let's run this now and see that it works, and it does work. So after this, we're going to need to start thinking about rendering a bit more clearly, how we're going to do the drawing, how we're going to manage that exactly. We've got a few more puzzles to solve as well, like how we're going to deal with colours and so on. But I'll leave it there for this tutorial. So until next time, happy coding.